Imagine a world where the internet is as universal as the sky above. A student in a remote mountain village, a student in a bustling metropolis. This is the promise of Starlink, a vast constellation of small satellites circling our planet designed to beam high-speed internet to nearly every corner of the globe. They fly in low Earth orbit, closer to us than traditional satellites, which reduces the delay in communication. This network bypasses the need for expensive and difficult-to-lay cables that cannot cross oceans, mountains, vast, empty deserts. It offers a lifeline of connectivity, transforming how we learn, work, and connect with one another. To build such a monumental system in the heavens requires an unprecedented pace of construction. That is where SpaceX and its workhorse rocket, the Falcon 9, enter the story. In the days leading up to a launch, an atmosphere of focused calm settles over the launch site. This is not the frantic energy one might expect. It is methodical, honed over hundreds of missions. Engineers move with purpose. Technicians move with purpose. Checklists and simulations guide every action. The Falcon 9 stands tall on the pad for final health checks. Every valve, every sensor, every line of code. Starlink satellites sit inside the protective fairing for a final check. Meteorologists watch wind speeds, assess lightning risk, track cloud cover. The pad area is cleared as the countdown enters its final hours. A profound quiet descends, only distant nature and the hum of machines. Screens in launch control stream live data on the rocket's status. The final phase begins with loading super-chilled propellants. Kerosene flows. Liquid oxygen flows. The rocket's skin contracts as fluids cool it. Vapor vents into the Florida air. The launch director polls each station in a call-and-response ritual. Below 1 minute, onboard computers take full control. The water deluge system primes to suppress sound and heat. The ignition of the 9 Merlin engines is a primal event. A brilliant flash of orange-white light blossoms at the base of the Falcon 9, instantly transforming night into day. The ground trembles as acoustic waves and a deep roar roll across the landscape. For a fraction of a second, the rocket is held in place. Then its engines roar to life, generating over 1.7 million pounds of thrust. The clamps release, and the rocket begins its ascent. It rises slowly at first, a colossal pillar of controlled fire pushing against Earth's gravity. As the Falcon 9 climbs, it accelerates relentlessly. The rocket pushes through maximum aerodynamic pressure, max Q, forces trying to rip it apart at their peak. But the vehicle is built for this, strong enough to withstand the stress. Onboard cameras show Earth receding below, the planet's curvature becoming more apparent. The sky shifts from blue to deep indigo to the blackness of space. The exhaust plume expands into a jellyfish-like trail across the sky. From the ground, the thunder fades, replaced by a distant crackle. It becomes a bright, fast-moving star racing toward the heavens. This is physics in action, Newton's third law on a grand scale. For every action, there is an equal and opposite reaction, lifting tons of metal and electronics out of Earth's gravity well. The ascent is brute force and precision. The guidance system continuously adjusts engine gimbals, finely steering the vehicle. Every second of powered flight is critical to place the second stage and cargo at the right point and velocity. The first stage burns for just under 3 minutes, consuming propellant with ferocious speed, performing its singular task to push the payload free from Earth. Roughly 2.5 minutes into the flight, a critical event occurs: stage separation. The 9 first-stage engines shut down, and silence replaces their roar. Pneumatic pushers nudge the stages apart. First stage separates, second stage separates. The vacuum-optimized second stage engine ignites. It pushes the satellites toward orbit. A wide, precise separation, a seamless handover miles above Earth. The payload fairing separates. Clamshell half 1 opens, clamshell half 2 opens. Fairing halves descend for recovery. Second stage fires for several minutes, accelerating to nearly 17,500 miles per hour. Engine cutoff, stage coasts. Second stage coast to the optimal point, prepares for deployment. No explosions. Tension rods release. Satellites drift away with a gentle push, like dandelion seeds. Onboard cameras capture the deployment, satellites glinting against Earth. Each satellite powers up, startup sequences run. Solar arrays unfold. Krypton ion thrusters deploy. Over weeks they raise orbit, arrange into constellation positions, ready to connect the world. This intricate dance repeats with every launch. As the second stage carries the satellites to orbit, the first stage booster begins its own extraordinary journey home. To begin its return, it performs a boost-back burn. Several of its Merlin engines reignite, pushing the booster opposite its travel. This burn cancels forward momentum and sets a ballistic trajectory back toward a concrete pad on land or a robotic drone ship at sea. The booster re-enters Earth's atmosphere, enduring intense heat and pressure. 4 titanium, waffle-like grid fins steer with incredible precision, like a skydiver controlling their fall. Constant, tiny adjustments keep the 14-story rocket oriented. As the booster approaches the landing zone, a single Merlin engine reignites. The blast of thrust breaks from supersonic to a gentle hover. 4 landing legs unfold. The 1.2 million-pound rocket, now mostly empty, touches down softly. The engine cuts off. The importance of reusability cannot be overstated. It is the single most significant factor behind SpaceX's ability to launch 100 times in 1 year. In the past, rockets were like airplanes that could only be flown once before being discarded. Imagine the cost of air travel if every Boeing 747 was thrown away after a single flight. The tickets would be astronomically expensive. Flights would be incredibly rare. For decades, the most expensive part of the rocket was thrown into the ocean, making access to space a privilege for the wealthiest. By successfully landing and reusing first-stage boosters, SpaceX has fundamentally broken this paradigm. Recovering the booster lets the company fly it again and again. Some boosters have flown more than a dozen times. This dramatically reduces launch cost. The main expense for a repeat flight is fuel and a much smaller second stage. This cost reduction makes space more accessible. It opens the door for more companies, more scientists, more entrepreneurs to build, to test, to deploy. Rapid reusability creates an unprecedented launch cadence. Instead of months or years to build, a refurbished booster can be ready in weeks. SpaceX can keep a schedule more like an airline than a traditional space agency. A high flight rate accelerates innovation. Every flight and landing yields data. Engineers study wear, feed insights back into design and manufacturing. It creates a virtuous cycle, more reliable, more robust, even easier to reuse. This rapid, iterative learning is a core reason the Falcon 9 is one of history's most reliable and capable launch vehicles. The direct impact of 100 Starlink launches in a year is the accelerated growth of a global nervous system. With each batch, the network's capacity and coverage expand, bringing high-speed, low-latency internet to the wrong side of the digital divide. For a family in a rural area, this means reliable access to online education, remote work opportunities, telehealth services. It levels the playing field for a small business in a remote town to compete globally. This connectivity is a powerful tool for disaster response. Hurricanes, earthquakes, wildfires. These events can destroy towers and fiber. Starlink can provide an immediate communications lifeline within minutes. Beyond fixed locations, Starlink transforms mobility. Airlines equip planes for gate-to-gate connectivity, even over oceans. Shipping fleets improve logistics, crew welfare, operational efficiency. Scientists in Antarctica, scientists deep in the rainforest, sending data back in real time. It untethers the internet from the land, a global mobile utility. The cultural and economic implications are profound. Access to information catalyzes progress. Online learning expands opportunities. Farmers increase yields and use resources more efficiently. Artists and creators in isolated communities share work with a global audience. Starlink is more than faster downloads, a tool for empowerment, an instrument of economic opportunity, a bridge connecting disparate parts of our world. The achievement of 100 launches in a year has implications that extend far beyond our planet's orbit. Technologies, operational tempo, manufacturing systems developed for Falcon 9 and Starlink are stepping stones to becoming a multi-planetary species. Lessons from rapidly reusing Falcon 9 boosters are applied directly to Starship, SpaceX's next-generation vehicle for the Moon, Mars, and beyond. Starship is designed to be fully and rapidly reusable, an evolution of principles proven by Falcon 9. A high launch cadence is essential for establishing a presence on another world, transporting habitats, life support, scientific equipment, and supplies. This cannot be done with a handful of launches per year. It needs a Mars colonial transporter system, an interplanetary logistics network launching hundreds of starships. Operational muscle and factory production rates from the Falcon 9 program are a rehearsal for supporting a Martian settlement. Precision landing technology perfected with Falcon 9 is critical for future planetary missions where thick atmospheres and infrastructure are absent. The propulsive landing technique, using engine thrust to slow for a soft touchdown, is exactly how Starship will land on other bodies. The Starlink constellation could inform networks around the Moon or Mars, providing high-bandwidth comms, HD video, real-time data, and reliable navigation. Experience building and operating Earth's Starlink is a blueprint for interplanetary communications infrastructure. The 100th launch is not just about connecting Earth. It is about building the bridge to other worlds. As we stand here on November 19, 2025 and reflect on this 100th launch of the year, we are looking at more than just a historical milestone. We are watching the normalization of spaceflight, a steady drumbeat marking the pace of progress. This rhythm, made possible by the relentless pursuit of reusability, has fundamentally altered our perspective. The heavens are no longer a distant, inaccessible frontier. They are becoming a dynamic extension of our own world, a place where we can build, work, connect. The journey, however, is not without its challenges. As we fill the sky with satellites, we must do so responsibly. Managing space traffic, mitigating the risk of orbital debris, ensuring the night sky remains accessible for astronomical discovery. These are critical responsibilities that come with this newfound capability. International cooperation, thoughtful regulation, will be essential to ensure low Earth orbit remains a sustainable and shared resource for generations to come. The same ingenuity that allows us to launch 100 times a year must now be applied to preserving the space environment. Looking ahead, this incredible launch cadence will only accelerate. As the Starlink constellation matures, as Starship comes online, the possibilities will expand exponentially. We can envision a future where launching satellites is as routine as launching an app, where scientific missions to study our planet and the cosmos can be deployed quickly and affordably. We can foresee a future where a permanent human presence on the Moon is not just a dream, but a thriving outpost supplied by a stream of reusable rockets. Ultimately, the story of the 100th launch is a story of human aspiration. Challenging assumptions, solving hard problems, refusing to accept that the old way is the only way. It proves that with a clear vision and relentless execution, we can make radical leaps forward. Each launch is a symbol of hope and a demonstration of our capacity to achieve the seemingly impossible. The sky above is no longer a limit. It is a vast and open highway. And as we continue down this path, we are not just launching rockets. We are launching a new era of possibility for all of humanity.